Okay, thanks a lot for showing up tonight, and I'm going to hand it off to Greg to talk about the new AI tools that he's starting to use. So go ahead, Greg.
All right, Dan, thanks for inviting me to come back and address folks in Missouri from here in nice, balmy Tucson. So I'm going to talk a little bit tonight about the two main Topaz tools that I've been using. There's a couple of additional ones, but I'm going to mainly talk about Denoise AI and Sharpen AI. And again, the idea behind these two processing tools is that they use some artificial intelligence algorithms to try to do a better job than the standard tools for denoising and sharpening images. So I'm going to go ahead and share my screen here. And hopefully everyone can hear me and see me.
Yes.
Okay. Yeah. I need to move the participants out of the way here. Okay. So what I'm going to basically do is kind of take you through the screens. Both of the programs have similar setups, just the tools do different things, but they basically look the same as what you see here. So this is Topaz Denoise AI, and up across the top here, at the top right-hand corner, there are a couple of primary ways you can view the image that you load. And I've loaded an image, a 16-bit TIFF image of M55, a globular cluster. And the first part of the thing you can do is you can zoom in. So right now it's zoomed to 100%, but you can zoom in even more, and you can move the little box around to center whatever part of the image you're particularly interested in denoising and sharpening. And I first started with this particular program because it was recommended to me by another imager. And so there's a lot of overlap between the two programs, and I'll touch on that a little bit in a few minutes when we get to the other program. But basically, when you zoom in here, you're selecting a smaller portion of the image to deal with, and that has two advantages. One is it gives you a close-up view, but it also down here at the bottom, when you change any of the settings here that we're going to discuss, it updates a little bit faster. If your computer has a dedicated graphics card, it automatically will allow you to use that when you install the program. I don't have that on this particular computer, and so some of the updates run a little bit more slowly because it's using the regular graphics card that's built into the motherboard. So the other way of viewing the image up here is to select how you want to view the original versus the processed images. And there's several different ways of doing that. There's a single view, there's the split view. The side-by-side view is the one that we're looking at now. And the one that's probably the most useful is the comparison view. And I'm going to switch to that. And what you'll see now is four different images based on the three different models that the program provides, plus the original image here in the top left-hand corner. So again, what you'll notice is that some of the little flags here are doing their thing and updating the images one at a time. And when they get done doing that, then they turn green to indicate that the images have all been updated in comparison to the original image. I forgot to add at the beginning that if you have questions as we're going along here, it might be best to just shout out your question rather than wait till the end, because sometimes it's easier to do the comparisons or to have me show you what the comparisons look like if there's a particular question as we go along. So this is the 4-panel comparison view with the original. Here's the standard denoise and update. This one down in the bottom left-hand corner is the clear, and over here is the low light model. And I'll explain briefly what each of those models do. So the standard model is the one that we're looking at the top right-hand corner here. And below it are the 2 main controls. And the controls are labeled remove noise and enhance sharpness. So I was kind of surprised to learn when I first started working with this program that its main objective is to remove noise and to use artificial intelligence to help you do that. But at the same time, it's got a sharpening function built in. And the sharpening function tends to work very well. In fact, on many images, I find myself lowering the enhanced sharpness down to some low number like 0 or 5, so that it doesn't over sharpen an image, which tends to look pretty good once you remove or denoise it. So again, the way these work is they're just numerical sliders from 0 to 100. You can think of them as 0 to 100%. And the algorithms that the artificial intelligence use are proprietary, but I assume that as you increase these sliders, more and more of the algorithm is applied to the image. So I've set up the different models here, all starting with a default value of 10, just so we can get kind of a comparison view. So I think you can see simply by looking at the original image here in the top left-hand corner versus the other models that there are some obvious differences as you look at them. So for example, the standard model here looks to be fairly well sharpened. The low light model is similar, but probably not quite as sharp as the standard model. And probably the least sharpened of the 3 are the clear model. So again, you can select whichever of those models you want simply by picking them up here from the selection where it lists the model. The one difference is in the clear model, the sliders go away and you're left with some like gross adjustments. You can do low, mild, or high for reducing the noise, or you can do low or high for enhancing the sharpness. And you can see that I've selected for that particular model, the one that's shown down here in the bottom right hand, the high. So this is kind of a really simple one that doesn't require a lot of fooling around with it. It just looks at the image and you can adjust going from low to medium to high. And you can see that it does those adjustments fairly quickly. So again, these are the models that are available. They each do something slightly different. The low light model, which is down here in the bottom right left-hand corner, is useful if you have a lot of bright stars that you don't want to over sharpen. And it actually tells you in the help file that you can use this if you want to reduce the amount of sharpening that occurs. And so you can see that the stars here in the core of the globular cluster tend to be less sharpened than the standard model that's up here in the top right-hand corner. So I'm going to switch now to just using the standard model and go back to the side-by-side view. So we have here the standard model. And to give you an idea of how you can exaggerate the use of these, I'm going to bump the remove noise up to about 50 and the enhanced sharpness up to around 50 as well. And so you can see that now we've sharpened and reduced the noise to a significant amount with some loss of color in the model itself. And what I've noticed from using the tools is that it's pretty useful to most of the time adjust these two sliders by the same amount, but not always. So for example, here we've adjusted the image to remove a lot of the noise at the expense of some of the sharpness. So if we lower the reduced noise back down to where we started around 10, you can see that we still have some increased sharpening now without the loss of, with still some reduction in the noise and some retention of the color. So again, what you typically need to do is to go to the comparison view and then try which model appears to fit the data that you're working with the best, and then adjust the sliders here to get the best reduction in noise and sharpening that fits the data that you're working with. If I bump the enhanced sharpness up even more, you can see that as it updates, the sharpness is improved a lot. And if we bump this up to 400%, you can see that we're beginning to get some artifacts between some of the stars. And typically, that's something that you'd want to avoid. So keeping the sharpness at a lower level avoids some of that, and adjusting the reduced noise can help with it as well. So again, the idea here is to adjust these two things so till you get an image that achieves what you're interested in without going overboard. And the problem with going overboard is not a big issue with the denoise program as it is with the sharpen program. And I'll show you some examples of that here in just a minute. Okay, at the bottom here are a couple of other tools that you can apply. One is their post-processing tools. One is called a recover original detail. And again, if you lose some of the detail in part of the image that you would like to retain, you can try increasing this. Let me bump it back up to 200% so we can get a better view. But you can increase this to recover some of the original detail, which I assume is just reducing some of the sharpening effect. Again, so this is a control that you don't use a lot, but for some images, when there's some fine detail that might have been lost by noise reduction, this allows you to get it back. I generally don't use that very much. The bottom one, however, does seem to work for some instances, and it's called color noise reduction. And I think if you have a lot of color noise in the image that you're working with, for example, if it's shot with a DSLR that's not cooled in the hot summertime, you may have a lot of background color noise. This particular slider can help reduce some of that. But for most images, you can leave that set to 0. So those are the main controls, and they're similar on the next program, which we're going to look at, which is dedicated to sharpening more than to noise reduction. One thing that's been added to both of these programs is the ability to use masks. And I don't use them a lot, but they are there and available. And you simply get to them by clicking on, down at the bottom here, the control that says mask. And you'll see then there's a different set of selection tools at the bottom left-hand corner. There's the radius of the mask, a softness setting, an opacity setting. And when you adjust those, what you have then is the ability to mask the object so that the denoising or sharpening only gets applied to the parts that aren't masked. So again, if you wanted to mask for whatever reason, if you wanted to mask this, you can click on it a few times to apply the mask, depending on how big you make it and how much feathering is involved. And then there are different ways to apply the mask under the options setting down here. So you could invert this mask. And so now you're masking the background star field and applying the sharpening tools and denoising tools just to the object of interest, in this case, the globular cluster. And so you can do various different things. You could fill the entire field and then remove some others. You can invert the entire field, or you can clear the entire field and delete the entire mask and go back to the beginning. Once you've set up a mask, you can accept that mask and then go back and do your adjustments. So in some instances, there are examples where you might just want to denoise the background and leave the galaxy or the globular cluster, whatever your target is, leave it alone. In those cases, the mask might be useful. So I'm going to stop sharing this screen, and I'm going to share the sharpener screen. And you'll be amazed that it looks pretty much identical to the other one, except now it says Sharpen AI. And the models up here and the setting tools are slightly different. So I've loaded the exact same image in just to give you some consistency. We'll look at a planetary image in a minute. But again, the zoom tools and the comparison view tools are the same. We can zoom in to 200% to get a close-up view. And we can go to the side-by-side or the comparison view so that we have the different models presented here. The models in this case are motion blur, which you see in the top left-hand corner, out of focus, which you see in the bottom right, bottom left-hand corner. Excuse me, the motion blur is in the top right-hand, and the too soft model in the bottom right-hand corner. So again, I've set each of these with the sliders at 10 as a default so that we can get a feeling for the comparison view. And once all the updates are done, all of these turn green so that we know that the software has done its thing, and we can look at the comparisons. So again, the blur model attempts to counteract the effect of camera motion. So this is designed for regular photography, of course, where your hand holding your camera and the object is moving or you're shaking. And this is designed to take the blur away. And so if the astro image that you're working with has what appears to be motion blur, then this one works pretty well. The out of focus model assumes that the focus wasn't very sharp. And so it zooms in on the individual parts of the image, and the out of focus model then tries to compensate for the fact that the image itself or the points in the image were not very sharp, and it tries to sharpen the images based on the fact that it thinks it might have been out of focus. The too soft model, as the name suggests, simply tries to compensate for an image that's either out of focus or has blur or is not exposed properly. And so it tries to compensate for one or more of those options. And so you can see that each one of these tends to sharpen the image a little bit. And if you look at particular stars in here, you can see that compared to the original image, they're slightly better. However, to get the best view, again, you can work with the sliders in order to see what happens. So if we take the motion blur here as our primary model, and we move up the remove blur, and remove blur is kind of the same thing as saying make this image sharper. And if I move it up to let's say 80, you can see that it takes a few seconds for the image to update, again, based on how much of the image we're looking at and how fast your computer is. And so now the image is updated. And you can see that the sharpening has been enhanced significantly, and there's still the ability to suppress noise in the image by adjusting the lower slider. So if you were gonna purchase one of these two programs, Denoise or Sharpen AI, I think the bigger benefit would come from the Sharpen program because the models seem to work better for sharpening, since that's what it's primarily designed for. And it has the ability to suppress noise or to denoise the background, if you will, simply by using the bottom slider. So for my money, it seems like it was a better deal. I think these things go for about $80 each, but if you buy one, they give you a deal on the other one. They have a whole suite of images that you can purchase, including gigapixel, which is good for enlarging your images. But if you buy one, you typically get a coupon for money off on the other one. If we look at the TooSoft and bump up the numbers there a bit, you can see that when it updates, the data looks better as well. So again, you kind of have to go back and compare the different models, and using the sliders, you can decide which of the models works best for you. The bottom post-processing slider down here simply adds grain. So if I pick, let's just pick the motion blur and go to the side-by-side view. And if I blow that up to the maximum of 400% and add grain, you can see that when you add grain, it simply adds some texture back into the image as it updates here. You can see that it adds some texture back into the image. And in some instances, you may want to do that. It doesn't come up very often, but sometimes adding a bit of noise can make the background look a little smoother, even though it doesn't look that smooth to start with. You can see that by bumping up the slider to 80 here, that we've introduced what appears to be a lot of artifacts. So that's probably more than you would want to do for this type of image. So I'm going to switch now to a planetary image. This is an image of Jupiter that I shot a few weeks back. The seeing wasn't real great, but it was pretty good. And what I found is that the Sharpen AI seems to do its thing quite well on planetary and lunar images because it can pick out specific details other than just point sources like we see when you're looking at a star cluster or a galaxy and some nebula. So again, if I blow this up to 200%, and we're looking at the motion blur here, but I'm going to switch us again to the comparison view just so you can get a feel for how the different models work when they're applied to a planetary image. And so you see, as each one of the models updates, the data down at the bottom here will tell you whether it's been updated or not. And basically it turns green when the update's been done. So you can see with a setting of 80 and 39 here, the motion blur brings out some significant detail. If we go to the out of focus and bump it up to a similar amount, it'll update. And if we go to the too soft, and it's already bumped up to the similar amount, and it'll update as well. We can then pick which one seems to do the best job. So again, all of them are updated now. You can see that the motion blur and too soft models both have enhanced the detail in the cloud belts here. The out of focus at the same basic settings, you can see has introduced a bit of over sharpening. And so there's probably a lot of data that's contained here that's not really real data that the artificial intelligence has tried to cull out of the data that's actually supplied. So if we go to the side-by-side view and just look at the too soft, I'm going to bump it up to 100% on both of those. So you can see what happens when you really take it up high. You can see that we get a pretty nice combination of enhancing the sharpness of the image as well as decreasing the noise that you would run into. If we look at the motion blur image and increase it a bit as well, you can see that we get similar type of increase in both the sharpness of the image as well as a decrease in the noise. So again, we can pick between the two models as to which one we like the best. To me, it looks like the too soft model actually does a good job, although some of this detail up at the top appears like it might be a little bit over processed. So again, because of that, I would probably stick with the motion blur model. Again, going from the raw data over here to the image that's processed here, it's difficult. There's data, background data here, but you maybe have difficulty convincing yourself that this is really the detail that's represented by the data that's back here. And the motion blur image, when it updates, will give us some similar improvement, but without quite the amount of improvement. You can see, however, that the image here seems to contain quite a bit of noise. And so we can counteract that, as I said before, by increasing the suppressed noise slider to deal with some of that background noise. And that helps with some of it, but not all of it. Again, if we want to reduce the add grain to 0 because we don't want to add any noise to the image. We'll give this just a second to update. So you can see now that we've reduced the noise a lot. There's no added grain. There's some suggestion that this is the image data that's represented by the raw data here. And again, if we reduce our view back to the back to 100%, you can see that the improvement appears to be a significant benefit over what we started with. It's going to take just a second here to finish. The last thing that I'm going to show you is the fact that both of these programs can be used as plugins to Photoshop or Lightroom. So I'm going to stop sharing this screen and share a different one. So this is the same image of Jupiter loaded into Photoshop. And I'm going to blow it up so it's 200%. And the first thing I usually do in Photoshop is to make a copy of the image so we can work on the copy of the image rather than the original, and makes it easy to compare. And again, both of these programs can be loaded as plug-in filters under Photoshop, and they show up in the filter list. And so if we go to Sharpen AI, you probably don't see that, but I'm going to go back to the Sharpen AI view of it again. And you can see that it's the exact same image that we had before. This time it's showing up in the filter view. So again, once we've, I'm just not going to do it now. So I'm going to go ahead and apply the sharpening function in the plugin here, and it takes just about a minute or so, depending on the speed of your computer. And so now we have the sharpened image overlaid on top of the original image, and you can see how much sharpening has occurred. Can everybody see that?
Yes.
Okay. So one of the benefits of using the plugin in Photoshop is that you can use the opacity slider in Photoshop to decide how much of the sharpening you want to apply. You can apply 50% or 75 or 100%, and then blink the images back and forth to see just exactly how much of the effect you want to do. So you can use the opacity slider. You can also use the blending mode to decide whether or not how you want to blend this. So for example, you might want to use the multiply blending mode and apply just a little bit of that multiply filter to increase the color saturation while you do the sharpening as well. So those are some of the advantages of using the AI tools from Topaz in Photoshop, which is where I typically use them. One thing that I didn't mention is that if you do use the blur filter to sharpen a planetary image, sometimes you get some nasty shadows around the edge of the image. And I assume that's because their proprietary algorithm is trying to move things over to compensate for the blur. And it looks at the dark side of the planetary image, and it moves some of the sky shadow over onto it. And so that kind of ruins the whole effect, which causes you to have to use one of the other models. So I see that happen not infrequently, but for example, in this particular image, it didn't seem to make a large effect. So that would be a way that you could go ahead and use the reduce blur. I'm going to stop there, and if you have any questions, I'd be happy to try to address them. No questions. Okay.
So Greg, have you adopted both of these tools into your tool bag and use them on a regular basis, or do you kind of find one that you like to use more than the other? How are you using them today?
Well, I tend to use them both depending on what's the main issue. If I have an extremely sharp planetary image or an extremely sharp image like the M55 globular that I showed before, it's pretty sharp just doing the regular processing. In that case, I might just go into denoise, turn the sharpening all the way off to 0, and just use the denoise filter to denoise the background. So again, I could use the mask in the filter that's built in, or if you're doing this as a plugin in Photoshop, you could very easily apply a Photoshop mask to mask the part of the image that you don't want to affect, and just denoise the background stars. What I find for planetary imaging, I typically use the Sharpen AI because it does a better job. There's more flexibility in terms of how you sharpen the image. Plus, it allows you to deal with to suppress some of the background noise at the same time. Not quite as good as the denoise itself, but similar. And I am assuming that the algorithms that they use operate in pretty similar fashions. I will tell you that when you apply these with regular daytime photography, with your regular DSLR photography of your family and friends, they really do a nice job, and that's what they were designed for. But they do a pretty good job on astro images as well. However, if you've got a really cloudy, poorly focused, or blurry planetary imaging, these tools are not going to make a silk purse out of what you start with. So in some instances, depending on what you're trying to do, sometimes it's better to leave the image alone. If you're trying to show the juxtaposition of a comet and a planet, or a comet and a star, you may be better off not to mess with it if it's not a very good image to start with. Sharpen AI will not do a miracle on it. It helps quite a bit, but again, it depends on the quality of the data that you start with. All right, I'm going to stop the share.
So Greg, do you use any of the other tools of Topaz?
I haven't used them, although some of my colleagues here in Tucson have used the gigapixel, which is basically similar to the tool I believe that Photoshop CC has introduced. It's a tool that allows you to blow up images with a lot of good fidelity. And a couple people that I know that use that have used that to blow up the image and then apply sharpen or denoise, and then take the image back down to its original resolution with the idea that those other tools function better. I haven't done that because I haven't bought Gigapixel, but they've reported to me that it seems to work well, in addition to the fact that you can blow up some of the images. I use the drizzle function in AutoStacker for my planetary images, and that basically blows them up 1.5 times. I now use the 3-time drizzle, but seem to get good results with 1.5 drizzle. But yeah, the Topaz, I'm sorry, I should have shared one last screen that I forgot. These are some other image processing programs that have been discussed for astro imaging that are available, that all use some form of artificial intelligence. So Luminar is the other one. It's kind of the big competitor to Topaz. PhotoLemur has some basic tools. Photoshop CC has some basic tools, and PaintShop Pro has some basic tools. But the Luminar is probably the main one that has a couple of different, or has a whole suite of tools that do fairly similar things to what Topaz does.
I just add that those Topaz tools seem to go, they're like a lot of the other software, they go on sale quite often. So I don't think anyone ever really pays full price for them. So if you watch their website, they have sales all the time. I don't remember if they have demos or not.
They do, and that's how I got hooked on this, is that I downloaded the demo and I found that it turned all the diffraction spikes on my poorly focused images into nice sharp diffraction spikes. And so I thought, well, that's a pretty good deal. I'm going to pay the $60 because it was on sale. So I think now, I haven't checked the prices recently, but I think they're all $79.95. And if you buy one, they give you a coupon for the next one. If you buy all four of them, it's $150 or something like that. So,
So Greg,
yeah,
that's my biggest problem is defocus, because I'm not careful about it, although I've gotten a motorized focuser now, so I'm more careful. But how effective have you found that it deals with moderate amounts of defocus?
well, as I kind of mentioned just a moment ago, if you have a nice round star that's big because of the bad seeing, it can do a lot with that. However, if you have an out of focus star, if it's nice and round, then the out of focus model will really work nice on it. In fact, when I downloaded the demo, what I did was I looked at some daytime images that had signs in them. And what I quickly noticed was that a sign that was not legible when you used either the motion blur or the out of focus tool, all of a sudden you could now read this previously illegible sign. So it does a really good job with some things. What I've also noticed that in some of my images where the stars are not quite perfectly round because of poor guiding or wind or whatever, when you apply these images to them, it makes them worse. So if you have an out of round star, the sharpen tool or the out of focus tool tends to make it worse because it tries to sharpen something it doesn't make an out of round star round before it applies the sharpening. So it's kind of a two-edged sword.
Talbot says, thank you for your order.
I'm sorry? I'm sorry, I missed that comment.
I think Steve was talking to someone else.
Oh, okay.
Unmuted now.
All right. Okay, well, if there's no other questions, I'm going to sign off.
But
This was
Thanks,
great.
Greg.
Thanks, Greg. Really fascinating.
Thanks, Greg.
Okay, download the trials and see what you think.
thanks.
Thanks,
All
Greg.
right.
Okay. I'd add that all those tools, most of them will use GPUs or graphic processing units. So if you have add-on graphics cards, they're immensely quicker because the graphic cards are a lot quicker than CPUs these days. Okay. Well, I'm not much of a PixInsight user. I picked it up probably 7 or 8 years ago. I went to a small class, and Adam Block had just started using it at the time, and we did a few things in it. But I mainly use it for annotating images. And PixInsight has had scripts that do it for a long time. But I recently found a new script that someone wrote that really changes the way it works, at least for me. In the past, what I've done is I create add-on or custom catalogs for certain things that aren't in PixInsight's list. And that's nice, but I found something else that I'll use. Every catalog that's on a particular site, only show you the objects that are in your image and then go from there. Let me try to share my screen real quick and see if I can get this working. One of my issues, I have several issues with PixInsight. One of them is that my main processing laptop only has Windows 7 on it still, and the new version of PixInsight doesn't work on it. So the one I have on this machine is a little bit different, but I should be able to get it to work. Okay, you see a PixInsight screen?
Yes, we see it.
Yep, I see it.
Okay, let me drag an image into it real quick. Yeah. Okay. Actually, not the image I wanted. Hold on. Yeah, I'll try this one. PixInsight, the process for annotating an image, there's tutorials out there, so you can easily Google for one of them. But you go into image analysis and you have to solve the image, and you just need the main thing that PixInsight wants is it wants the image scale to be fairly close. This particular scope is 2430 millimeters, and then I typically pick whatever the object is, so it kind of centers on that, and it makes it much quicker. So let's do that. I'll talk about this in a minute or two. Goes out to the visor site and solves it. That's fairly quick. And then the next thing you would do is the render and annotate image. And by default, it has a bunch of things here. I just pick the defaults and hit go. And so, is there any easy key to make this full screen?
Yeah,
Yeah,
you
that
almost
plus
had
sign
it. It's
on-
that
on
little
the
up
right.
arrow next to the plus, to the left of the plus sign. Oh, or not.
Yeah. As you can see there, using the default catalogs, it picked up NGC's M78 here, NGC 2064. Let's go back in here. And kind of what Steve had asked, you can change on the list, you can change all the colors, the sizes of the circles around things. You can change anything you want in here. You can also create multiple layers. You can create layers on top so that you can do, Astrobin does like a mouse over type deal. So that's pretty neat. You can also, PixInsight has a bunch of catalogs. If you hit plus, and it shows these are some of the ones that people have come up with.
How did you do that? I've never seen that.
The plus,
Oh, wow.
yeah,
I was
lots,
looking for dark
lot-
nebula. Oh, neat.
yeah, this one's kind of neat because it has LBN and LDNs already in there, which is really good for the nebula stuff. It also has some, constellation lines, borders, you name it. There's quite a few things already in here, including stars used for photometry and things like that. These are the AVSO catalogs. It has the Gaia, I might be saying that wrong, data releases of, this has got 1.8 billion stars in it, things like that. So it doesn't have, one of the things it doesn't have, like this particular picture has a bunch of these HH objects in it, and it doesn't have those. And so in the past, what I've done is create a custom catalog. And there you can look on PixInsight's site, and it'll tell you how to download the data from the visor into a spreadsheet, and you can make a custom catalog, and that works fairly good. But it's something you have to do every time, or you got to keep these catalogs around. In the past, one of the things I've done with that was there was a AL NASA challenge on, let's see here. Oops. Yeah, oh well. On finding exoplanets. And so what I did was I made a custom catalog of the exoplanets that were known at the time and used it, and it allowed me to create something like this, which is just a small field in Cygnus, I believe. Each one of the things in green is a known planet. But this new script I found, which I find really interesting, is that let's see here. We can just use this image. There's a guy by the name of, let's see here. How do I do this? Stop share. Screen.
Testing.
Okay. Sorry, I have too many windows open. A guy by the name of Herbert Walter, I believe his name is, or at least that's what this website says, but here it says Harmut Bornman. This guy has developed a lot of different scripts. Some of them are already in PixInsight with the default distribution. One of his big ones that's there now is this game script that's used. But I think some of these others, like the Mass Gen and some of these others on his list, are already built in. But I found that he came up with this TypeCat script. And what this thing does is it pulls up a different screen to find catalogs, and you can select any one of something close to 200 catalogs, click a button, and it'll show you all the objects that are in your image, or should be based on the field of view. And at that point, you can click on it to pull up information from the web on them, or you can hit another button to create a custom catalog. So let's do that real quick. Let's see here. What I did was I downloaded the script, you put it in a directory, and there's a command you run that'll reindex them and it'll show up on the list. So it's called TypeCat. And these are all the catalogs that you can access. Looks like there's 214 of them. For my particular image, I was interested in these here HH objects. Yeah. So I can hit that button and hit this, and it shows me these ones are in my image. If you want other things, you can, let's see, something else that's probably in there. Dark cloud. Let's see if there's any of those. Yeah, there's some of those. The dark cloud, it'll bring up the LDNs, which is neat, but it also gets these Dobashis that there's a lot of those. At that point, you can actually click on these. It'll pull up the Simbad website and show you more information on them. But usually at this point, I save a custom catalog, which is called 1.1. And then when we go into the annotate, the render and annotate image, we can go down to the bottom and pick custom catalog. And once you click on that, let's see here, you pick the catalog file. Labels 15, let's make them something that really pops out. Lime. And hit OK. And then you can see that it annotated these other things that were in that new catalog. This is actually kind of neat if you image like a Bell Galaxy clusters or things like that. You get images that literally have hundreds of galaxies, and they're not all in the PGC catalog. This will annotate those as well. One other thing that I found, when I was first starting out, it was interesting to get asteroids and things like that in your images, but now if you point at certain places in the sky, you almost always get asteroids with the bigger telescope. And so let's see if I can make this bigger. So PixInsight, the newer versions, I believe it's resources. This one is 1.8.8-9. I believe it's 1.8.8-8. They have some new catalogs which allow you to annotate your asteroids. They have pre-built catalogs that you can download from the distribution system that go up to, I think, numbered asteroids up to something like 250,000 or something like that. There are ways to create more, but I started it through the list today and it looked like it was going to go for about a week. And this particular machine that it's running on, I believe, has 24 cores and lots of memory. So they supposedly are going to have machines or something to build these things so that people don't have to. But let's go into the render, annotate image. Oh, I gotta solve it first. No, let's do solver. I think it makes for the moving objects, you really want to have the date in there. And I believe this is in UTC time. I think this is about where it's at. I don't remember. Day 14 hour. Okay. That should be good enough. Let's see if that solves. This is ARP 8. Okay, that solved it. So let's go to, let's see here, render. Okay, in here it has an asteroids already, but you notice it says 343 or something like that, which is I'm not even, it doesn't include, it's not 1 through 343 either, it's other ones. So it really doesn't help. They have these, I'll turn off that. They have these XEPH files that you can download from their website, and they have ones that go up to I believe, numbered asteroids up to 250,000. The asteroid file that I download for asteroid work now has something like 1.1 million lines in it, or 1.1 million asteroids in it. So there's a lot of them. But let's pick that file, and this is the particular file. I've already picked it that has the numbers of the asteroids that's in this one. So let's see what it does here. Well, obviously it didn't find it because there's an asteroid right here. So let me try that again. Maybe I didn't pick the right file. I don't know, PixInsight, one of the annoyances for me, and I don't know if other people have the issue, is PixInsight doesn't seem to work for me if I try to load the files off of network storage drives. And so I have to copy things onto my local PC.
Yeah, it doesn't allow you to do that. I think it's a license protection thing. All my images have to be on the same drive as the client.
Don't remember. Let me sorry, let me find the image. I don't remember the date or whatever on this image. I just want to make sure that it show you that it works. Yeah, I have to pull my image. It frustrates me to have to do that. And then I don't like, you have to continue reinstalling it and uninstalling it every version for some reason. They haven't quite figured out.
Yeah, that's annoying to me
Modern
too.
installers.
It's kind of frustrating, you know, and then I have to go back to my scripts and reload the repository and remember all that, or refresh it and so on. It's
Yeah, yeah.
I mean, it's not that bad, but it's just a little annoyance.
Okay.
Hey, while you're here, I don't mean to interrupt your presentation. There's an option that I found important on output mode. See, it says apply STF before annotation. So so it's applying a screen transfer function to the image. If I'm just doing a test, I leave it there, but I usually uncheck that because I usually do this on processed images and I don't want it further processing. So I don't know, just something to think about.
Okay, yeah, definitely, because everything I pull into here, sadly, is already processed. Okay. Well, I do not know why it's not working. It worked when I tested it, but I'm missing something simple. Maybe I didn't copy off over the right. Usually it will find the asteroids that are in these if you're
Is it checked? Was it checked in your list?
I thought it was. Let's go back here one more time. I'm wondering if yeah, it's this here.
Yeah, so it's
Yeah,
checked.
the
And then
file.
before you leave, so one thing to goof around with, this is just probably my problem, but the width, if it's a high resolution image, I can't see the labels and markers sometimes, so I make them much larger.
Oh,
That's probably not your issue.
9. Let me see what the date on this was again. Sorry. 9/8.
Did you have to
Oh.
use that date when you did the image solve?
I didn't. I don't think it matters, but I just noticed that I had this on 2020. So let's see if it definitely wouldn't have been there in 2020. Yeah, there, it got it. Of course, it's microscopic. as he said. You say
Ah,
it, see it
Yeah,
pretty
cool.
close.
nice.
And the asteroid work, when you do it, if your clock's off by a second, it can, it can be fairly far off from where it thinks it should be. And I also find that these files are not always accurate. But yeah, it's a neat thing to do if you had a file or they come up with a file that has more asteroids in it, it would be a good way of detecting asteroids in your image. That would be it'd be automatic pretty much, but right now they only offer 5 catalog files, and the deal is one catalog goes from 1 to 50,000 and stuff like that. And once you get above 2 or 3,000 in the asteroids, the magnitude can be all over the place. So you can have an asteroid that's 500,000 that has a magnitude of 14 at the time, whereas asteroid 2000 might be 21. So it would make it rough to ad hoc try to find asteroids right now, because the other issue is that they only have lines to load 3 of these files. So it's like I said, this is the file that has asteroids 50,001 to whatever the next level is, and that's the reason why it gets that asteroid.
Hey, Dan, again, I don't mean to interrupt you. What are the, you showed the plus sign that adds something. What's the up down arrows? Does that change the order of the layers? What
Yeah.
shows up on top?
It does, and part of that is that some of the stuff, as you check it, it will, as you change the order, it changes what actually displays on the image. In other words, if you put PGC first, it will show PGC numbers,
Will
and it
override.
will show NGCs if they're underneath it.
Got
If
it.
you pick an there's options in here that says remove duplicate objects, and it tries to prevent, I think, giving you M1 is NGC this, is PGC this, and stuff like that. So I think it'll only give you the top one if it shows up in all 3.
Yeah. Oh, right. Yeah, that's good. Thanks. That reminds me, there's this other option there. You see under general properties, it says write objects to text file. I use that on occasion. If I've got a busy field and I'm updating my logbook, it'll give you a list of all of the objects that it found and labeled.
Yeah, I use that as well. It works really good. The
Yeah.
only annoyance I find with that file is it formats it in a way that sometimes it has line feeds and other times it doesn't. And if you display that particular file with different programs, you get different results. The numbers are the same, but I'm not exactly sure what it does.
Yeah, that's interesting. I load it into Excel and strip it and reformat it.
Well, like I said, I'm no expert in this. This is my 5-minute figuring out with it. Like I said, PixInsight is great for annotating things, and I use it for a lot of my objects that I do for Astronomy League programs where there's a bunch of, if there's a bunch of NGCs or galaxies in an image, I'll use PixInsight because it can, it's a couple clicks and it gives you an image, and also writes that text file that shows you all the other ones that are in it. And it's a lot easier than doing it manually.
Hey, Dan, I use this pretty often myself just to just keep track of what I've imaged, and just sometimes it surprises me with things I didn't realize that were in the image. But I would say close to 10% of the time, the image solve fails for me. And I'm really surprised at that because there's so many, so many algorithms out there for doing that, and they always seem to work. But for some reason, I don't know what it is, whether it's a setting I have or some history in previous image solves, it must get confused and cannot solve it. And I was wondering if you have that problem ever.
I've never had that problem at all. As long as I set those, either the image scale or the other one that's underneath it and above it, as long as I'm close and I pick an object that's kind of in the center, it never seems to fail for me. The new version, actually, there's some settings in there. You can actually use local catalogs too. And they allow you to download the, on PixInsight's website. What is that?
Yeah, I have had that exact same problem where it just seems to frustratingly not solve, and I don't understand why. And what I find is if I reset it, there's an option to reset to factory defaults and just start fresh, it'll solve it. And I don't know why, but I think what is going on is as they update the script, it's optimized different ways, and the default star catalogs work better in some versions than others. So again, I just find if I reset it to factory defaults and start fresh, it'll often solve.
And I found that same thing, but even then, there's still a subset of images that won't solve, and I end up having to go back to one of the raw subframes that have been calibrated, and most of the time that will fix it. But now I've got a annotated subframe without any color and that sort of thing.
You know what? One thing I can guarantee that I can't get images to solve. If I do some kind of deconvolution or something like that on them, it tends to make it so that they don't work in certain programs. But I've never had that issue with PixInsight loading my final image in.
Okay.
I just had this problem last night, actually. I found that if I'm in a really dense star field, like in the Milky Way, and pretty wide angle, that once the image is stretched, it has a really hard time solving. So I keep a copy of the unstretched and I solve that. And then I use the copy coordinates command to copy that solve over to the processed image, and then it's happy again.
Okay. All right.
Yeah, that I've used that in other programs too.
How do you copy the coordinates? Is there a process for that?
Yeah, there's a process called, I think it's literally called copy coordinates.
Okay.
So it's a little bit backwards from the way my mind works, though. You go to the image that you want the coordinates to be in, the one you can't solve, and then you take copy coordinates and pick the image you want to get the coordinates from.
Okay. All right. I'll try that next time I have that problem.
And I'll upload the image to nova.astrometry.net, solve it, and then cut and paste the coordinates off there. Sometimes works too.
Okay.
The one other thing I was going to mention is the newer versions of PixInsight allow you to use local catalogs too, that you can try. The newest Gaia catalog, I think if you download the first one here, it has, what is that, 119 million stars in it, and it can be quicker than going up to the web to do stuff.
Okay.
I'm not sure if it'll help with solving though, but I'm not sure that the positions in this particular catalog are better than any of those other catalogs. Nobody had anything else. I also found another script. I noticed a lot of the PixInsight people use a script called, what is it called? StarNet++. You guys heard of that?
Yes.
A lot of
I've
people.
heard of it, but I don't understand it.
A lot of people, the way they process images is they, the old style way. Well, my way is I don't use any mask. I just globally do everything. There are people that create masks for everything. In other words, they'll mask the stars. In other words, so that they don't do any processing of the stars. They'll process everything else, and then the stars haven't been touched. The new style way of doing that is a program called StarNet++ that runs, and I believe it interfaces with PixInsight somehow, and it will more or less find all the stars in your image, make some kind of mask, or just remove the stars altogether. Then you can process your image to your heart's content, and then you can put the stars back in. It seems like there's a lot of magic to that program. You get lots of people. It works for some people, doesn't work for others. It uses, it's another program that uses GPUs. But for us other people, Russell Crowman just came up with a new tool in the past week or two called StarXterminator. And his is an AI-based tool, much like the Topaz stuff, that he sets up. It's got some kind of neural network that he trains, and I don't quite understand everything behind it, but it's all AI-based. And this particular tool works for Photoshop and Affinity Photo, and he claims that he'll have a PixInsight version out soon. It might be worth looking at if you're into these kind of tools. This particular one requires recent versions of Windows. It runs much quicker if you have higher end graphics cards that can do everything on the GPUs. And it's already gotten much better through input from I guess the neural network that he has and some of the people using it. And the Cloudy Nights people seem to think it does a much better job at this point than StarNet does. Now that it's been tuned a little bit, and it seems like every version of this he comes out with gets better. Again, it's something, if you still use Photoshop or Affinity Photo, it might be worth looking into. And I'll post something when there's an actual PixInsight version. But I don't know, just something new.
And can I add something to your StarNet
Yeah.
conversation? Just something I found out yesterday because PixInsight stopped working for me. And I heard from the PixInsight people, if you have a new Mac computer with an M1 chip, you have to uninstall the StarNet if you want to run PixInsight. Otherwise, it instantly crashes the program. So I don't know if anyone has a new computer, but I do. So can't use the StarNet.
Well, now there was some silence. Jeez, Mike just put a pause in there. Seriously, because of a chip? Once